Hello guys, hope you have been having a lovely day. In this video, we'll be learning about time and work. So basically with time and work, the most important thing that you have to keep on your mind is a simple formula. I wouldn't really call it a formula because it is basically a simple logic. If a person X can do a piece of work in n days, then that person, the amount of work that person can do each day or in a single day is 1 by n. That's it. That is the only thing that you have to know for solving time and work problems, and every sum that you get is basically a spin-off of this. So they're gonna tweak your sums in many different ways, and I will try to put in as many scenarios as I can in this video so that you, when such a sum comes, you can say, hey, this is that model. So I hope you will be able to relate to those sums. So the second thing is, if if uh, and in these problems they always compare people. If there are two people, A and B, and A is five times more efficient than B, in that case the ratio of work done by A is to B is going to be 5 is to 1. That's it. That's as simple as it. And the ratio of the number of days or the time taken by A to B is going to be 1 is to 5. So the things that usually are tested in this time and work problems are your basic problems. These are very basic problems which have simple things like I'll just put them through, you will understand. The next one involves ratios, and where the scenario where they get multiple people, and then the scenario where they give you the count of people. Okay, I'll try to solve a couple of these. So the first example that I would like to give you in this category is, let's say there is a person A who can complete a piece of work in, say, 10 days, and there is a person B who can complete the same piece of work in 15 days. So how much time would it take for both A and B if they worked together? So this is your question. So this is a very basic question, and this is something you will be able to finish in just just a couple of minutes. So the first thing that you have to do is, your A person, he is taking 10 days to complete the work. And here you're calculating how many days does it take for both of them together to complete the same work. So the amount of work done by A in each day is 1 by 10. So A can do 1 by 10 of the work each day, and B can do 1 by 15th of the work on each single day. So each single day, A and B would complete 1 by 10 plus 1 by 15th of the work. So that is 30, 3 plus 2, that is 5 by 30, 5 ones and 5 6. So A plus B can complete 1/6 of the work each single day. So what does that give you? A and B, when they work together, they can complete the work in 6 days, because each day they can complete 1 by 6th of the work. So this is a basic problem. I will give you another basic problem, something like this. So it is basically a spin-off. So this question says A and B can complete a piece of work in 15 days. And the question says A alone can complete the work in in 20 days. Okay. Now the question is going to be how many days would B alone take to complete the same piece of work? So this is basically the exact same thing that we have done here, except in a different way. So here A is doing 1 by 20th of the work each single day, and we don't know how much B is doing, right? So let us think that B is doing 1 by, so let us think, let's just put B as B, shall we? Let's not complicate things. So A is doing 1 by 20th of the work each single day. So A and B together, they can complete 1 by 15th of the work each single day. So now, to know how much work B is doing each single day, we have, see, A plus B is 1 by 15th of the work, and A is doing 1 by 20th of the work. So what does that give you? B does 1 by 15 minus 1 by 20. So what does that give you? 1 by 15 minus 1 by 20. I'll use this. So 15 and 20, that would be 60. 15 fours and 23s. So that would be 1 by 60. So B does 1 by 60. I don't know, guys. I hope it's not getting clumsy, but you get the process, right? So B is doing 1 by 60th of the work each single day. So it would take Mr. B 60 whole days to complete the same piece of work all by himself. So this is how the other type of questions that can come from the same situation. So in the first case, we have there is this guy who does it in these many days, there is this guy who does it in these many days. How many days do both of them take together to complete the same piece of work? So that is your first type of question. Your second type of question, you have these two guys together take these many days. The first guy takes only these many days. How many days does the second guy take? So you see where both of these are going. They're basically the same thing put in a different fashion. So the second thing which we saw is also a basic problem. So now I'm going to solve something that has let's put in multiple people, shall we? Let's think of something like this. Let's bring in 3 people, X, Y, and Z. So let's say X and Y can complete a piece of work in 9 days. Y and Z can complete the piece of work in 12 days. And Z and X can complete the same piece of work in 18 days. So now I want to know how much work can 3 of them do together. So I want to know how many days would it take for if all the 3 of them worked together and worked separately. So this is slightly above the basic level where it involves multiple people and it has a little bit of color to it. So let's and this is again very simple, guys. So you have x plus y is 9 days, y plus z is 12 days, and z plus x is 18 days. So you want to know how much work they do together, right? So that is basically x plus y plus z. When all three of them work together, how many days are they going to take? That is what you want to know. So now you have x plus y, they do 1 by 9th of the work. Y plus z, they do 1 by 12th of the work. And z plus x, they do 1 by 18th of the work. So now I will just add all these three equations together. So I have x plus y plus z, all of them taken twice, right? So you have 1 by 18 plus 1 by 9 plus 1 by 12. What is the multiple, guys? 18 nines, is that the multiple? 18, 8, 9 and 12, so 72. Okay, 72. So 18, I have, that goes 4 times, 9 goes 8 and 12 goes 6. So 10 and 18 by 72, that is 1 by 4. Okay, so now this is twice, right? We just added them, so this is taken twice. So if this goes this side, I would have x plus y plus z or z is 1 by 8, right? So three of them, when they work together, they do 1 by 8 of that work each day. So they would take 8 days to complete the work together. So looks like our Z person is not very fast. So X and Y they're able to do it in 9 days, but if if the three of them are doing it together, it's only going to save them 1 day. I mean, I just took an example. So this is the situation where there are multiple people, and oh yeah, there is the separately thing, right? We haven't got to that. So now this is simple. You have x plus y plus z is 1 by 8. So now you want to find out how much separately. So now I have four different equations. I have x plus y plus z is 1 by 8. So if I need to find out how much x is doing separately, I just need to subtract y plus z or z from the whole equation. That would be like the amount of work y can do alone all by himself is x plus y plus z minus x plus z. That would be 1 by 8 minus what is x plus z. X plus z is 1 by 18. So 1 by 8 minus 1 by 18. So 18, 8, 16, 14. Okay. 18 minus 8. That would be 10 by 144. So I'm just taking example, guys. So if you have y do the work all by himself, he would do 10 by 144 of the work on each day. So y would basically take just reverse the equation and you would get 14.4 days. So Y would basically complete the work all by himself in 14.4 days. So now you can apply this and do the same for X and Z if they want to. So I want to keep the video short and I want to go further for similar kind of sums. So the next kind of questions that you get is ratios. So these are the questions where they say, and these are again really basic and simple. So when it comes to ratios, they always have two people or three people, whatever. I'm just starting with two people. Excuse me, I'm sorry. So you're gonna say X is 3 times more efficient as of Y. So the time taken by both of them, is let's say 10 days. That feels like it fits the equation. Anyway, so both of them take 10 days to complete a piece of work. How much time would each person take? So this is a very simple problem. So the amount of work, convert each guy's work in terms of the other. So I have X and I have Y. So when I have X, X is thrice as powerful as Y. X is thrice as efficient as Y. So the equation goes like X is to Y is 3 is to 1. So these are the ratio problems. So X and Y can complete 1/10th of the work when they work together. So now divide it in such a way that what is X portion in this? So he does 3/4 of the work and Y does 1/4 of the work. So now it gets simple. I mean, instead of 10 days, I could really use something else here. I could, let's say, a multiple of 3. Let's say 9 days, just to be simple. So X is going to do 1 by, okay, both of them are going to do 1/9th of the work each single day. X is doing 3/4 of the work and Y is doing 1/4. That is what we're getting from the ratio. So now when I want to find out how much of part X is doing, X is 3/4 into 1/9. That is 1/12. So X alone will complete 1/12 of the work each single day. So X would take 12 days. Whereas Y does 1/4 of the work and he completes 1/9th of the work together. So 1/4 of total work. So that would be 1/36th of the work each single day. So Y would take 36 days. So this is how ratio problems are dealt with. So the other scenario that you have while solving the problems related to time and work are the situations where you're given a count of the people. Say 30 people complete the building construction in 50 days, right? And then after they have worked for 10 days, the company added 20 more people. How many days to complete construction? So this is the other type of question that you have very frequently. So in these kind of questions, always know that all these people have the same capability. One is not a Steve Jobs and the other is not a random guy. So in these cases, everybody has equal capability to do the work. So I have 30 people doing the work in 50 days, right? Now, how much work can one person do each day? That would just be one person's work each day would be 1 by 1500. So one person can do 1 by 1500 of the work each day, which means each person is going to take 1500. I mean, one person is going to take 1500 days to complete the construction. So anyway, that is not what is important. What we need is this: how many more days to complete the construction. So now 30 people have worked for 10 days, right? So 30 people have worked for 10 days into 1 by 1500, because that is the amount of work each person each day. So into the number of days into the people, right? So now I have ones, fives. So 1/5 of the work is done. So 1/5 of the work, it's done. So the work remaining is 4/5, right? And now I have 50 people, right? So now I have each of these 50 people, each person working at this capacity, right? So the amount of work that can be done each day now is 50 into 1 by 1500, right? So that would be 50 by 1500. So that would be 1 by 30th. So 1 by 30th of the work is done each single day when you have 50 people. So if you have 50 people do the work, you can finish the work in 30 days. Simple. But it's not the complete work that is remaining. It is only 4/5 of the work that is remaining. So the number of days it would take is reverse. So 1 by 30th, right? So 1 by 30th of the work is done. So 1 by 30 into X number of days to complete 4/5 of the work. So the number of days would be 4 by 5 into 30, 6 fours, 24 days. So your normal simple basic question would have something like 30 people can complete in 50 days, and how much work is being done by them in 1 day, or something like that. But here in this question we have 30 people who can do the work in 50 days, and then after 10 days you are adding 20 more people. And how many days to complete the remaining work now? So this question, you can twist it and tweak it and probably add another 10 people after 10 more days, right? you could you know tweak and twist it like that however you want it. So this is the problem where we have count of multiple people. um, Finally, I would like to give you guys a final scenario where um, so most of your questions will be based among this. Some of them will include money. um, in questions like this, say this person is 3 times better, you need to figure out how much money that person is getting. If the entire amount of work is 10,000 rupees, how is it going to get divided? Those are the kind of questions. I mean, you won't be given the ratio in those kind of questions. You're going to be given something like this. Say there are 3 people, they are going to take these many days together. Then you're going to find out how much each person is capable of, and then do a ratio of that, and then find out how much share each person gets. So that is how you're going to deal with money in there. And the other thing which I wanted to tell you is, the previous example, we assumed that people are all of the same capacity. But now, let us think of a situation where there is a difference in the capacity. Let's say there are from college A and college B. 5 people from college A and 2 people from college B can finish a piece of work in let's say 2 for this guy, 16 days. Okay, I'm just throwing numbers, guys. And 3 people from college A and 7 people from college B can finish the same work in, let's say, 9 days. Okay, I'm just throwing in rough numbers like that, I don't know. And the question is going to be, how many days are um, 2 men from college A and 5 students from college B going to take to complete? So this is a simple equation. So 5 students, 5 men from college A and 2 students from college B complete 1/16 of the work each day, right? So now here I'm assuming that A and B are the amounts of work done each day by the student or the man from that specific college. And in the second equation I have 3A plus 7B is 1/9 days. So now you have to solve these equations. How is it going, guys? This multiplied 3 times, right? And this multiplied 5 times. That's the only way, right? So now I get 15A plus 6B is is 3 by 16, and 15a plus 35b is 5 by 9. Okay, so now 29b is 5 by 9 minus 3 by 16. Is it 144? Right? 16, 80, 16 nines, 27. So now I have uh, 53, right? So there you go. So now I have B is 53 by 29 into 144, right? Solve it, guys. Just solve it. And then from this equation, you also get the value for A. So now substitute those values in this 2A plus 5B equation to get a fraction 1 by something. So that something 1 by, let's say 1 by x. So that x is the number of days they're going to take to complete the work. So this is how you can tinker with simple equations when you're given questions like this. So this is where they have different capability, and this is where they have the same capability. So that is all about time and work, guys. Hope you have found this video informative. Hope it helps you in your exam, and I wish you all the very best for your placements, your CAT, your or any other competitive exam that you're taking. All the best. Thank you. Thanks for watching.